Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 8 March 2025, and today's problem is closest prime number in range. So as I already always said that first we will try to figure out that what could be the problem statement. We will not miss anything, but at first we will try to imagine that what could be the problem by just reading the title of the problem for the quick response, so that we can increase our efficiency and we can give the output in a very short interval of time efficiently. So the problem is title is closest prime numbers in range. So what could be the problem? It says something about the prime numbers and something closest in range. There might be some range that could be given to us, and we have to find out the prime number, closest prime numbers, because here it is the numbers. So that might be talking about multiple numbers, and because it is in range, so of course it is obvious that it is trying to ask us about a range of prime numbers and what is the closest. So but from the title we couldn't be able to figure out that what could be the meaning of closest in the problem. So now we have to move on in the constant. What the constant are given, constants, some variable are there like left, I mean the argument. Then there will be the two argument left and right, and it will vary from 1 to 10 raised to the power 6. So this is the constants of the problem. So from the constant, because it is 10 raised to the power 6, so we have to think a solution that should work in order of n or maybe n log n. So from till now what we have concluded that there might be some range of prime numbers, and our solution should have the time complexity of order of n, linear time complexity or partially linear. I from partially linear means n log n or n log of n, something like that. So let's try to read the problem statement now. Before starting to read the problem statement, we can also see what is the prompt are given here. So the prompt that are given is closest. There are the two variable given, left and right, and you have to find out the closest prime number in range. So let's try to read the whole problem statement now. So given, before reading the whole statement, we will just try to read quickly, and we will focus only on the keywords that are given in that. So that the two positive integer, okay, that will be the positive integer, right, left and right. Find two integers, num1 and num2. So basically we have to there will be the positive integer left and right, and you have to find out two numbers that are num1 and num2, such that the number 1 should be greater than or equal to left, but should be less than to the next number, and the next number should be less than or equal to the right that are given as a argument in the method. So both, and what it said that both and num1 and num2 are prime numbers. So you can, from the title you can remember that it was asking about the prime numbers, and it is also saying that both the numbers should be prime number, and the difference of these two prime numbers is the minimum among all other pairs satisfying the above condition. It means that there should be the two number, because we are checking about the prime numbers. Of course that there will be the different prime numbers, and so if there is the multiple prime numbers, so smaller we will put first and then larger. So if you will find out the difference from larger to smaller smaller prime number, then it should be the minimum, the difference should be minimum among all. And it means that if you have like multiple prime number like 2 3 5 7 11 something like that, so you have the multiple, you can pick up any two prime number, and you have to find out the minimum difference. You have to choose that pairs which give the minimum difference among all. So because you need the minimum difference, the prime numbers that have the minimum difference. So from here you can see that 2 and 3 are always give the minimum difference, but there is one more condition, that we do not always select the first two number, but instead of that, the problem is asking that you will have the two variables argument left and right. In between left and right, you have to find out that what could be the all prime numbers, and what could how we can choose two different prime numbers in between left and right, including these two. You have to find out the that two numbers that should be prime and their difference should be minimum. So written the positive integer array nums answer, just like num1 and num2 if there are the multiple pairs satisfying these condition. So return one of the smallest num1 values. So if there is the multiple multiple pairs that is giving you the same minimum difference, so in that case you have to find out the minimum value of num1. If there is no such number exists, you have to return -1. So let's try to understand the example one. As input are given left equal 10 and right equal 19. So in this case output will be 11 and 30. How it could be possible? Let me show you here from the sketch. I will explain you that how we will be able to find it out. So here from 10 to 19, as it is asking from 10, it is the range from 10 to 19 you have to find out. The square bracket means that it should also be included. So 11 will be the prime number, 13 will be the prime number, 14 for now, 15, 17 is the prime number, and 19 is the prime number. So because you have to choose any two pairs, but if you will, because they are in the increasing order, so if you will choose this one and last one, they will give you the maximum difference, but we have to find out the minimum difference. In that case, what we will do, we will pick up the adjacent one. So from here to, you will either choose these two or these two. There might be the three possibilities. So from the difference 13 minus 11 is 2. Okay, from 17 and 13 it is 4, and from 19 to 17 the difference is 2. So you can see that we got two minimum value with the same differences. 2 is also here, 2 is also here. So in that case you have to select the minimum num value. So we will have to select these two pair instead of these two. So the output will be 11 and 13. So now let's switch to the problem. So you can see that 11 and 13 are the answer. So you can read this, what is given here, what I have is similar what I have explained in this part. So now example 2 from 4 to 6, there is one more statement are given that if no such value exists, return -1 and -1. Let me show you an example that how -1 could be the possible. Let's say that your like left is given like 13 and right is given as 15. So in between 13 and 15 only one prime number is there, so only the 13, you find out that only the 13 is the prime number in between this range. So in this case you can do not have the second number because the problem is asking that both numbers should be the prime number. So in this case the answer is -1 and -1. There might be one more case that we have like something, let me tell you that from 14 to 16. So in this range you will not even find a single prime number. So in that case you have to say the answer will be -1 and -1. So this is the problem statement, and similarly you can read the 2 to 6, from 4 to 6, 4, 5 and 6, and all the three from 4 to 6, 4, 5 and 6 all no, only the number 5 is prime number, but you have to at least you should have two prime number in the range, but there is no two prime number in the range, and as it is asking in this condition, so the answer is -1 and -1. So this was all about the problem statement that are given to us to make a solution. So how we can proceed it? So there is an algorithm. If you don't know how to find out the prime number, you have to first understand the algorithm. The algorithm name is sheaf of Eratosthenes. Sheaf of Eratosthenes. So this was the algorithm. What this algorithm says that if you are trying to find out the prime number that should be less than or equal to the n, let's suppose n is 10. So in that case you have to find out all the prime number in between from 1 to n. So let's say that there is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 1 0. Okay, so this is all the numbers that are given to us. So from 1 to 10, what we will do is that let me bring you the basic that how we try to find out the prime number. So to find out the prime number, at the beginning we try to think, oh, a number is a prime number if it has only two factor, either is 1 or it should be itself, either the number itself or a number 1 should be its factor only. So let's say that 1, and it should be start from 2, not from 1. So 2, because 2 is divisible by 2 itself only, and 1 is also the factor, so 2 will be the prime number. In the similar way, 3 is also the prime number because no digit can divide the 3. So 3, and then 4 is not a prime number because it can be divisible by 2. 5, because 5 cannot be divisible by any other number except 1, so the 5 is also a potential candidate for the prime number. Now the 6 is divisible by 2, so we cannot consider it as prime number. Now the 7 is again the prime number. It is not prime number because it can be divisible by 2 as well as 4. 9 is also not a prime number because it can be divisible by 3 only. And 10 because it can be divisible by 2 as well as the 5, so it is also a prime number. So the total prime number is 2, 3, 5, 7. These are the prime number. So this is the way how we try to find out the prime number in the given range. We always try to find out that if the number is divisible by any other number or it is only divisible by itself only. So this is the basic thinking, that how we try to find out the prime number. But this is very brute force approach of the problem. But if we will try to find out what is the sieve of Eratosthenes algorithm, it actually says that okay, you are trying to find out the prime number. So no problem that if we will mark, we will assign a array. In the array we will consider that okay, all the number starting from 1 are marked as true. That is, it is the, I'm considering that it is the prime number. Sorry, I wrote you. So 3, 6, 7, 8, 9, 3, 6, 9, and 10. So all the number I will, at the beginning I will say that it is a prime number, and I will start from 2. So because we do not consider 1 as the prime, prime number, so we will start from 1, 2. So because 2 is the prime number, okay, I said 2 is the prime number, and I will mark every number that is the multiple of 2 as false. So 2, so let me make it easy for you. This is the 3, this is the 4, and this is the 5, and this is 6, and this is 7, and this is 8, this is 9, and the last one is 10. Okay, so this is 10. So I will say that 2 is the prime number. Okay, I will mark every multiple of 2 as false, so it will become false, false, and it is also false. Alright, so every multiple of 2 is now considered as non-prime number. So now we will iterate to the next integer, that is 3. Okay, and I will check that either is the prime number or not. If it is the prime number, then I will mark other multiple of this prime number as false, indicating that these number are not the potential candidate for the prime number. Actually that are non-prime number. So 3, from 3, 3 to the 6, 3 is the 9. So it's saying the 9 is also not a prime number, so no problem, but I will say that I will mark it as false. So you can see that for the 3 we started from there. We should from where we should start, because 3 is already the prime number, so next number is 6, but you can see the 6 was already marked as false. Okay, then this is 9. So from where we should start? Okay, now number 4 is already false. So for the 5 is the prime number. So the next multiple of 5 is 10. But the 10 is already marked as false. That is, it is a non-prime number. So I have a question that, okay, I am trying to check that if the prime number is the prime number, then I am marking all other number as a non-prime number. And in the similar way, I proceed further in the further iteration. So she have optimized this in a two-way. So let me code you. Let me code if at the same time I will explain you that how the sieve of Eratosthenes will help you to optimize the problem of finding prime number in the range. So comment this out. So I will say that, okay, I will assert a variable that will be, okay, I will is prime, sorry, boolean of size n. Okay, this will, so for int I equal 0, I is less than n, and I plus plus. Okay, at the beginning I will find out all the prime number in between from 2 to right plus 1. So this is that. Now it will not start from 0, but it will start from it will start from 2. I should be less than or equal to, because there will be the right plus 1 number. Should I? No, it will give you the index or top bound. No problem. Okay, now for int I equal to, sorry, j equal to I. Either we can start from 2 into I, and then j is less than or equal to n, column j plus plus. And if is prime I, sorry, it should be the outside, control X. So this is like control V, and then okay. If the current number is prime number, so also we have to is prime as for, sorry, as true. At the beginning I will mark every number as a prime number. So if it is the prime number, so from h prime select j equal to false. So this is the way, this is the brute force way that we can find out the all prime number from 2 to n. Okay, but here you can see that from we are iterating from 2 to n, and again we are iterating 2 into I. It means that I n, so it is still n square times, but here the constant is 10 raised to the power 6. So this, of course, this will not work. So how we can optimize that? Okay, instead of starting from 2, as we have seen that when we move further to the next element, next candidate for the prime number, all the other factor of that prime number is already marked as false. So this start from I into I. It means this from I square you have to check out that either it is a prime number. No, you do not have to check the it is prime number or not. You have to mark it as, because it is the multiple of that candidate, so you have to mark as false, because that are violating the principle of prime number. So this way we optimize it to find out the prime number. One more thing, that okay, we have optimized something, but still it's something like root of n. You can say that it is starting from n square I square, but from I square it is again, if there is like 10 number, I square is 2 to this 4, from 4 to, so it is still not fair enough to pass this constant. So there is one more clue, that okay, into I is less than. So as you have also seen, that we have also seen earlier that there are the few number that is, instead of moving till the last number, we just move to the root of n. To root of n we square both sides, then it will become I into I square. I square means that I into I is less than n and I plus 1. So from 2 we will check the root of till root of n, and from here that if that is number of prime, we will mark all the multiple of I as false. So this is the way that we can be able to find out the all the prime number. So let me, it's -1 and we have to return the, sorry, now okay, from, so we will get the prime number from 2 to right plus 1. Now we have to check that we'll make the integer list. So you can see that, and one, we will start from the next integer 1. So there is one more clue, that okay, no, we will start from 2 till n. Here we will move till n, and I will check that if is prime, which is 2, then we will add in the list. Okay, now from here we'll check if here it is x, and then we'll mark this okay. N1 is less than 2, because we must have at least 2 number. There's no 2 number, we will return answer. Instead of that, if that is not true, mark as N1. make a variable difference equal to integer, because we have to find out these two prime number that have the minimum difference among all. So that's why I made a variable of difference integer, and we will find out the current difference from, we will start from 1 and we'll find out the current difference equal to list dot get it I minus list dot get it what I minus 1. I will say if difference is previous difference is greater than current difference, so in that case I will append the answer equal to new int of size 2, it should be list dot get it I minus 1 comma list dot get it I. Okay, and I will also have to append the difference. We will not start from 1, instead of starting from 1 we will start from math dot maximum of 2 comma left, because the prime number will start from 2. If the left is given is 1, that have no meaning for us, because we do not consider 1 as a prime number. Prime number always start from 2, so that's why it is that. And then sort of 1 minus sort of 0, we have to return the answer, as I have already written the answer. Is there any more problem? No, I think not. Let's try to run the code now. So this is giving the not the correct output, saying that this minus 1 and minus 1. Okay, it means that this minus 1 let me check that either it is giving the correct answer or not. It is saying only 2 and 3. And where's the remaining element? From I equal to sorry, it should be plus equal I, because that is the gap. We should not mark all, but we should mark only the multiple of that number as non-prime number in the false. So now it's again same with 2. Okay, now it is prime number, we consider it false. We have already make it as 2 from right plus 1. Let's say this. No, we say 2. The difference is the current difference. If there is current difference, then I let me check the size of size list size. is and 1. This size is saying is 8. So where's the problem? Talk from 10, 11. Okay, no. Said what? We cannot add every number because we have to add the number, sorry, from here. From maximum to less than or equal to right. It's saying the minus one. Why is that? It means that it's never going to this one. Difference is always the maximum. So in that case, it should go inside, but I don't know. It's not going to enter into this one. Let's say one more thing. System that how to current difference. Let's say diff difference and current difference. Okay, let's run now. It is not going to enter into this loop, so that's why there is the problem. Sorry, it should not start. It should start from 0. That was the issue, because in the list we have only not from 0, from 1, because in this list we are just considering that element that are in between the left and right. So all the member that is in the list might be the candidate. You can choose any one of them. We have the uh, we have the we have the choice to choose any one of them, but we have to find out the minimum. So at first I will find out all the potential candidates. So that's why from left to right I will append all the value that are in between and left and right, and then I will from 1 to n minus 1 I will check it out. Let's see what is happening. So now you can see that all the test cases that are available here have been passed, giving the correct output. So I will comment the output part and then I will submit the code. Now let's try to submit it now. So you can see that our code have been submitted and successfully accepted as well. So it took 95 milliseconds and it beats 62.30% of the people that have been submitted in Java. And in case of memory, it is 50.20 MB and beats 42.86% of the people. So for the time complexity, because it will be the time complexity of Siva Eratosthenes, Siva Eratosthenes. So, what will be the time complexity of this one? I think that's just n log of n. don't know exactly, so I will check it out there. Time complexity for this one. So that is, you can see that time complexity is order of log of n, because the outer loop is root n and the inner loop is n by pi. So the summation of this series 1 by 3, 1 by 5, 1 by 7 is or prime is log of n. So that's why n log n. The time complexity is n log n. So you can also read it out if you want to know the explanation of the time complexity, why it's n log n. So the outer loop has the time complexity of n and the inner loop has log of n. So that's why the total complexity is n into log of n. So our solution have the time complexity of, where is that? Sorry, this one. So the time complexity of order of n. So let's try to see their features. So you can see that the time complexity of n of log of n. So this is all about the problem. So you should understand how actually sieve of Eratosthenes, and what is the algorithm for this one. It is very simple algorithm. You have to just do this one. Only these 5 to 6 line of code give you the all the prime number that is in between the given range from 2 to n. So this is all about the problem, and anything left? No. So if you have any query or suggestion, you can ping me below in the comment box. Whenever I will time, I will surely reply you and I will appreciate your comment. Thank you. If you feel that my videos are helpful for you and it is helping you to improve your coding skill, you can follow my channel. You can also share with your friends who are interested in coding. So please share, subscribe, like and comment in the below comment box. Thank you. Have a nice day.